Particle-wave duality, the backbone of quantum mechanics. The ability of everything in the universe to act as both a particle and a wave at the same time. But what truly is the difference between a particle and a wave? Stick around and we'll show you. Particle-wave duality has more to do with probability than anything else. What scientists have found after much research is that everything exists everywhere at the same time. If you look at any object, let's take a photon for example, in each of the innumerable positions in the universe, there's a distinct probability that the photon will exist in each of them. So if we make a graph of the probability of the object existing in a certain position on the y-axis, and a list of all of the positions in the universe on the x-axis, we get something that looks eerily like a wave. In fact, what we truly mean by saying something is a wave is exactly that. It has a certain probability of existing in every single position in the universe. Let's wind back a second. Remember when I said that everything exists everywhere? Well, that's not entirely true without a certain qualification. Everything exists everywhere except for the moment that it is measured. When we graphed the object as a wave, every position in space had a distinct probability of that object existing there. When we measured the object and graph it as a particle, however, something strange happens. One position has a 100% probability of the object existing there, and all other positions have a 0% chance of the object existing there. The property of an object having a 100% chance of existing in a certain position is known as its particle nature. Let's go back to waves for a second. What numerous experiments have shown is that these waves, though seemingly just graphs of probability, are actually real things. If everything has a probability of existing everywhere, then, logically, each position in the universe contains the probability of every single object in the universe existing in it. Scientists have observed that those objects with the highest probability of existing in a certain place interfere with one another, meaning that they change the probability of each other existing in that specific position. In actuality, all objects interfere with one another, but the objects with the greatest probability of existing in a certain position interfere much more significantly than others. These are called interference patterns. Yeah, I know quantum mechanics gets weird. We'll pay for any damage we cause to your brain. Just let us know if we damaged it with the like.